Hello friends, welcome to Java2D tutorial. In this sub-series, we are going to see how to convert an image to a grayscale image. Then we will save the converted grayscale image into the disk. So in this 5-part series, you will know how to use a draw image. Draw image we already saw in the previous 2 videos. Then you will see how to use get RGB function, then get red, get green and get blue, then set RGB. So all these functions will be useful if you want to work on a image pixel by pixel. When we use buffered image class, we can work with the raw data of the image. We know pixels are packed in row and columns. The same if this is the image, an image will have width and height. That means pixels are packed width and height wise. So it will grow like this, and there will be pixels here. So each pixel will have some color attribute, and these pixels are, there will not be any gap here, and the pixels are tightly packed. That means we can say it will be like this. So here you are seeing a grid of 3 x 3 pixel. So this is a 3 pixel width and 3 pixel height. So this is 3 pixel width and 3 pixel height, and each pixel will hold some color information. So that's what here we are saying. We know pixels are packed in rows and columns, or we can say height and width is decided by these rows and columns. In this sub-series, we read an image and convert it into grayscale image. So we know how to read an image. In the previous video we saw it. Here in this sub-series, after reading the image, we will manipulate the pixels so that the pixels will be grayscaled. The algorithm is simple. Say for example, we read the red component and we will multiply that with a constant 299, then we will store that back into the red component. Similarly for blue, we will multiply that with a constant. Green, we will multiply that with a constant 114. So red, blue, green will be rearranged in the so it will be rearranged to get a grayscale. So here, if you see red, we will be reading from the existing image pixel component. So a pixel is combination of red, green, blue color information. So we read red and we will multiply that. So each color value will range from 0 to 255. And when you multiply this, we will be getting a value between 0 and 255. Here if you see, the red component intensity is reduced to some extent. Similarly blue and green. So a higher weightage is given to the blue component. The next higher weightage is given to red, and green lowest weightage is given. So once we get all this, then we will sum up RGB to get a value that we need to set to the grayscale. So if we set same value for red, green and blue, it will fall under some of the grayscale area. Grayscale in the sense it varies from 0 to 255, and we will see what happens when we set same value for RGB component towards the end of this video. Once you change RGB component as above, we can repack the image and make it as a grayscale. Say for example, let's consider one pixel. Let's take this one So this pixel stores a color, and it's a combination of red, green, blue component. We will retrieve red, green and blue component. We will apply this algorithm and we will get a value from 0 to 255. Then we will set this value for all the component red, green and blue. That means we are setting the same value. So for example, if the resultant color value is 120, we will set that 122 or G and B. So if you set same value to RGB, we will get a grayscale between 0 to 255, and we will repack that pixel with the grayscaled color. So once we do this, or once we apply this for all the pixels, we will be getting a grayscale image. Alright, finally, once we have a grayscale image, previously we used image.io.read, right, to read the image from the flat file, and now in this subseries we will make use of write as well. So we will use both read and write. Read is to display the color image, then we will perform the image manipulation pixel by pixel. After that we will use the write method to put back the image in grayscale format. So in 32-bit images, 8 bits are for red, 8 bits are for blue, and 8 bits are for green. And there is one more bit, right? So this will give 24-bit red, green and blue. And when we talk about 32-bit image, there is 8 more bit available, and that bit is used for alpha channel, and we call that as a ARGB image. So 24-bit images are for red RGB image, we can say, and 32-bit images are ARGB image. So this alpha channel is useful to perform, say for example, this is used for image transparency. You can set image opaque hair transparent. Alright, so a 32-bit image contains 4 components: red, green, blue and alpha component. So with an integer, we know that integer is 4 bytes. That means 32 bits. A byte is 8 bit, right? So since a byte is 8 bit, 32-bit integer means it's a 4-byte data or 32-bit integer. So we can represent a pixel with all this information. That means one pixel we can store in one integer. So if we have an integer, the integer has 4 compartment or 4 byte, and in one integer, so if it is integer x, in that we can store one pixel information. That means we can store R, G, B as well as alpha. In each pixel we can retrieve the color component using get RGB call. So as already told, let's take an image. So it's a 4x4 pixel image. So we know the screen resolution, right? Some people in old Windows system, well-known pixel or resolution is 800 x 600. So resolution also we will specify, right? Yeah, screen resolution. So 800 means 800 pixels arranged width-wise and 600 pixels arranged height-wise. So likewise, this is a 4x4 pixel taken for example, and each one here denotes a pixel. So in each pixel we can retrieve the components red, green, blue component using the getRGB function. So using this function, you can retrieve red, green and blue component. Then you can perform manipulation, and after that you can put back those components using the function setRGB. So this is how you will do the image manipulation. So you retrieve color information from a specific pixel, you will manipulate it, then using the setRGB you will put back the manipulated image pixel on a specific location. And if you have an image of 800 cross, let's say 900 cross 300, and you can perform a scan on each pixel, you can do the manipulation and put back the pixel. So that way you will be doing the image manipulation. Alright, so now let's go to the demo to understand how pixels are working in image. Here I am in a paintbrush, and when you click resize, you can see the resize window. Here I am clicking on pixel, and if you see, this pixel here tells horizontal there are 32 pixels and vertical there are 32 pixels. So that's how the image is formed here. We can see this as a 32 cross 32 image. Here, if you see, this is also an image, right? Now, if I go to resize pixels, here you can see this image is 835 cross 471 pixel based image. That means horizontally there are 835 pixels and vertically there are 471 pixels. Alright, now we will go to file new. So we have 32 cross 32 image. We will zoom this to the maximum 800. Now we will draw a diagonal line. So I'm holding the shift key. So because when we draw diagonally, you will see the pixels clearly. Let me pick line here. Here if you see, even though we draw a line, you will be seeing a pack of a rectangle here. So let me turn on the magnifier here. Here if you see, each one looks like a rectangle, right? And each one of this is actually a pixel, and the pixel contains some color information. So let me pick or let me draw one more line here. So I'm holding down the control key. So drawn one more line diagonally, and you can see here we are seeing big square, which is a combination of 4 pixels, one pixel here, one here, and there will be some other pixel in the bottom. Now let me change this magnifier to original size, and we'll close this. Now let me pick a specific color. And if I take the pencil icon here and make it to the smaller size, remember we are in 32-bit 32 pixel image. That means 32 cross 32 means width wise there are 32 pixel and height wise there are 32 pixel. And here we will be seeing 2 pixel horizontally and 2 pixel vertically. So let me change this pixel by picking some color here, green. So or let me click black so that you can clearly see it. So 1 pixel got changed. So now you will get an idea of how we can manipulate the pixels. Now if you see, the red is changed into green. Sorry, red is green turned into black. Now 1, 2, 3, 4. So this is how we can manipulate the pixel. Now let me go back to the original size, 100, and if you see, this is how the image works. And when we are at original level, you won't see the pixel detail at all, and what you are seeing here is a red cross mark with some dot in the middle. Right, so this is what we are going to do in this sub-series. That means we will load the color information or the image, and then we will manipulate the pixels so that we will turn each color into a grayscaled one. So now let me open the Cocoa copy, and let me copy a specific portion of the image. File, new, paste it here. Here you can see the pixels. So somehow the pixels are visible, right? This specific portion, if you see, this is in different color, and this one is somewhat a black color, and you can see how the leaf is forming. Let me go back to magnifier once again. And I will change this to 300 cross 300, and you can clearly see how the pixels are arranged here. So this pixels is, or the pixel color is actually forming the leaves of the coconut tree. You can take any image, there will be pixel information, and if you see the color information on this cursor location, so this cursor location, it's different from the color information on this pixel location, but all these together forms the leaves of the image, or all these together forms the image. All right. Okay, forgot to tell one more information. Now let me go to edit color, and if you see, the color here is a blue, and RGB component value, you can see the RGB component value, and when I move, you can see how the RGB value is changing. Now let me pick grayscale value, and if you see, all component values are same, and when I move this towards the bottom, when red, green, blue all reads 0, we will be seeing a black color. Here you can see the tile, and if I go to top, when all color values are at high intensity, it means 255, we will be seeing a white color. A grayscale, you can see here 0 to 255 how it is changing. So if I am in the middle, this is a grayscale value, and red, green, blue value is reading 138 pixels. I mean a value of 138. So the idea here is all three color component holds the same value. If they holds the same value, we will end up with a grayscale. So this is the grayscale that varies from black to white. 0 for black, for white it is 255, and when I move the arrow downward, you can see how these component values are reduced, thereby forming a different grayscale value. You see? Alright, so by reading the red, green, blue component value, we use the algorithm as discussed in the slide, and we give higher weightage to the blue. The next higher weightage is for the red, and the least weightage is given to green, thereby forming a value between 0 to 255. Then that value is applied to all red, green, blue component. If I come here, I can go to pick a color at a specific pixel. So this is a color pixel at the specific one. When I go to edit color, if you see, red is 39, green is 51, and blue is 47. So it's a kind of a color. So this falls under somewhat green. Here the marker shows. But what we will do, we will adjust this red, green, blue to the same value by giving a higher weightage to the blue, the next higher weightage to green, and red, and final least weightage to green. Then we will set everything with the same value. So for example, here let's say I'm setting everything with 51. I will end up with a gray value. If we take this one, red, green, blue, that means blue is the highest precedence, right? Next is this one. So for example, let's state the value coming here as 123. We will apply 123 for all the components, thereby ending up with a gray color. So this way we will put back the pixel information for all the pixels, and we will turn the color image to grayscale. So now you got a good idea of what is how a color is stored in an image, and in the next coming videos we will do the image manipulation. Thank you for watching. Bye.